Welcome to a very special episode of Life is But a Stream. I have the pleasure of filming on-site today's episode to discuss data streaming, streaming agentic AI, and our fantastic strategic partnership with Google. My guest today is Sean Falconer. Sean, so nice to see you. Can you tell the audience what your title here at Confluent and what your areas of focus are?
Yeah, absolutely. So I'm the Senior Director of Product and focus on AI and AI strategy at Confluent.
Fantastic. Yeah. So here at Confluent, we often say that AI problems are fundamentally data challenges. Can you unpack that for us?
Yeah, so if we even look at sort of what are the data requirements for powering these types of models, especially as we've gone from sort of the first wave of AI of like purpose-built or statistical models to now foundation models of generative AI. Most people in the world of foundation models, we're not building models, we're kind of building applications on top of models.
Sure.
And these are great. Like these are really powerful models have been trained essentially on everything that's publicly available on the internet. There's only a handful of companies in the world that are going to do that work. And they package it up in this nice API where as an application developer, I don't need to know anything about deep learning or neural networks or how any of this stuff was constructed. I essentially just call an API endpoint. That's the only thing I need to know how to do. And I get this like AI magic out of the box.
Right. And that worked.
Yeah, and it's amazing. But as powerful as the models are about sort of general information, when it comes to your specific tasks or your specific needs or information about your customer, it doesn't know anything about that. It's pretty dumb about your business. And the only way essentially to get it that information is to feed it that data during something called prompt time assembly with a fresh representation of that information. Sure. So if I want to do something, I want the model to do some sort of reasoning related to my customer, then ideally I'm giving it the freshest representation of my customer as possible. Otherwise, it's going to make decisions that are maybe not in the best interest of that customer or the best interest of my business. Just like an employee sort of operationalizing against static or stale information, it's going to lead to mistakes. And you see the same thing when it comes to these models.
Right. So if the objective is to present it the freshest data streaming is a great way to achieve that. So speaking of continuous data flow, let's take a step back with the basics. So for our listeners who aren't data engineers, can you describe what data streaming is in simplest terms you can give?
Yeah, I mean, I often use, I like the analogy around, Lego. So,
okay.
If I wanted to build, I have kids, so I think I naturally go to toys. But if I wanted to build something out of Lego, or my kids wanted to build something out of Lego, there's sort of the mode where I can wait for the Lego factory to manufacture Lego, right, deliver it to a toy store. I can go to the toy store, sort of buy bulk and bring it home, and then we try to build something. And that's kind of like the traditional batch way of handling data. So it's kind of batch system. I go and collect all this stuff. Now I have it all available to me, and we can start building. Now, an alternative to that would be that somehow the place where Lego gets manufactured, those bricks basically go directly from the manufacturing and get distributed to everybody who wants to have it. You fan it out to essentially everybody as soon as the brick becomes available. And that way, I don't need to wait for all those bricks to kind of get assembled, go to a toy store, and then me go and retrieve them to start the building process. I could be building essentially as those bricks become available. And that's really what data streaming essentially is all about, is I can take this information that as it's being generated, I can essentially be essentially reacting to that data immediately and not waiting for it to collect somewhere and then accessing it.
Right. The second I have that brick, I can be inspired. So I've been here for 5 years, and it's the first time I've heard that analogy for data streaming. So I'm absolutely going to steal that from you, just so you know. So why is this conversation so urgent right now? What is it specifically about agentic AI that pushes the traditional data exchange methods to their breaking point?
Yeah. So I think there's a couple of different things. And one of the big things is if you think about, what an agent actually is, and there's no sort of widely agreed upon definition.
That's true.
And I'm not overly pedantic about it, but I like to think of an agent essentially as it's really just like a software system that has some level of agency to make dynamic decisions, and is using these powerful models to kind of help facilitate that dynamic decision making. And there's different levels of how dynamic and how fluid that really is versus something that's completely deterministic, which is what the history of software has essentially been. We pre-program a bunch of if-then statements into the software, and it's reacting based on that pre-programmed behavior. With agents, we're using this model to do some level of dynamic decision-making. In a lot of ways, that kind of mimics how humans think and process things. So if I take a human process, like crossing the street, I have a lot of history of successessly crossing a street that I can draw upon. Thousands and thousands of times I've crossed the street.
Evidence by you being here right now.
Yes, exactly. So far, so good. And I have kind of like this database, I guess, of serves as this kind of long-term memory of me being able to do that I can draw upon. But if I don't take into account what's happening in the moment,
right?
Sort of, if I closed off all my sensors, my eyes, my ears, maybe my smell, I don't know how much of a factor that is,
Sure.
But I close off all those things and then tried to cross the street, I probably wouldn't be here right now.
Right.
So you need really, for human decision making, typically you need a combination of factors. You need sort of sensory, real-time signal information and knowing and understanding what's happening in the moment, as well as historical information, so that you can draw on these patterns of behavior that you've done successfully in the past. I think the same thing when it comes to agents is we need essentially, obviously, to understand maybe what a customer's history is with us.
Right.
But I also want to know what they're doing in the moment. Where are they on my website? Where are they interacting with the product? These other types of things. And for most companies, they have decent data systems in place for sort of that historical data. We've been doing databases for 50 plus years.
Right.
People kind of understand to some level that domain, and there's our challenges there. It's not perfect,
right.
But people kind of understand that.
Sure.
The real-time side is something that a lot of companies have historically, underinvested in as an overall strategy.
Absolutely.
But it becomes even more of a requirement when you're trying to build these kind of powerful AI systems.
Yeah, it's interesting when you use that analog or the analogy of the stoplight, right, or crossing in traffic. Because most times, like in a controlled system, just following whether it's green or not is sufficient. But we know that people run red lights, right? So providing that fresh data kind of gives all of the angles that allow this, like you said, non-deterministic system to make the right decision. Because I imagine at some point, we're going to get to the point where we don't even really understand the thought process behind the LLMs.
I don't think we do now.
Right, I don't think we do now, right? So providing it everything gives us an opportunity, or gives it an opportunity to do things that we're not even expecting it to do. And I really think that's kind of the magic that I'm seeing now. Let's talk about a core challenge. Data exchange between agents built by different teams. What happens if we cannot find a way to effectively allow agents to communicate with each other?
I think it's kind of has similar characteristics to what we've seen with data systems historically. A lot of companies are plagued by these data silos that get created. Different teams
Absolutely.
are, running their own databases, their own data systems that don't necessarily talk to each other, exchange information.
Data integration is a big space.
It's a multi-billion-dollar, maybe trillion-dollar market. So that has been a problem that's existed for a long time.
Okay.
And we haven't fully solved it.
Right.
There's different approaches to trying to solve it, but that is something that, plagues a lot of companies that they try to get a handle on. But with AI, in particular AI agents, I think we're kind of potentially creating a similar type of problem, but instead of data silos, there's kind of like these intelligence silos. So you have these islands of agents, essentially. Yeah. So I can have a bunch of agents that I built in one platform. Maybe it's my CRM. And then I have a bunch of agents that maybe are built on top of my warehouse. Maybe I have a team that's building agents and running them in the cloud using whatever, agent SDK that they want to build with. But none of those communicate with each other, then you're creating essentially these different intelligence silos and not sort of sharing information. So if one team ends up building an agent that can analyze customer behavior in order to create some sort of offer that's compelling to them, well, that can be useful in different parts of the business. You don't want to have to keep rebuilding that agent over and over again. Just like that's why things like APIs exist, and we have these different processes that we've developed as sort of good architecture for software. And I think one of the problems I see in the market right now is everybody's so excited to charge ahead with AI that we're kind of, sometimes it'd be helpful to kind of slow down a little bit and just think about how should we think about this as a real investment as a company, and what is sort of the things that have served us well from like traditional software engineering and software architecture that allows us to build scalable systems successfully. We have to apply those same platform learnings to building AI systems as well.
Yeah, it makes a lot of sense to me. There's these isolated agents, isolated intelligence. It's really just a next generation data silo or integration challenge for the future generation. So let's build these things the right way. And building on that idea of communication, let's define a key term. What exactly is a streaming agent, and how does it differ from a siloed chatbot that many of our viewers are probably accustomed to interacting with at this point?
Yeah, so a streaming agent really is about embedding these agentic capabilities directly into the data stream. So the way I like to think about it is these become the eyes and ears of the organization, the sensors that are reacting to these business events. So a lot of what is being built today and people are used to interacting with are more these sort of chatbot experiences.
Right.
And I think part of that is, you have a hugely successful consumer-facing product like ChatGPT.
Absolutely.
We've now kind of strongly associated, like, of course, the natural interface into AI is going to be a chatbot. Sometimes that absolutely makes sense, but there's a lot of times where wouldn't it be better if something just understood when it should actually take action and understand sort of my business events because a customer is complaining about something, like, should I have to go and like user prompt that to find out is someone complaining, or should I just automatically do it?
There's probably data points that can tell you this customer is calling into the call center constantly. Things that could be what's the word I'm looking for? It just could be not implied, but deduced by an intelligence. That makes a lot of sense to stream it that way. So how does that lead into the streaming?
Yeah, and we've also been doing that kind of thing for a long time around like alerts and alarms that we set up in like our cloud systems or other types of systems, but they're basically restricted to just being a fire alarm for someone to go and investigate. But with streaming agents, what you're doing is essentially you're bringing that agent capabilities to take that beyond just an alerting or some sort of heuristic-based way of measuring that something happened, or egressing that event to some other system. You're bringing the agent essentially to where the data exists, where the real-time contextual data exists. And you can always reach out to other systems, the static data. That's kind of the easy part. How do you bring essentially those workloads as close to the source of the information as possible so that they can react in the moment and take a proactive stance? We have at Confluent, we have customers that do these types of things for monitoring the supply chain. And historically, it's like you wait until something goes wrong and then you react to it. But can you get ahead of those problems and start to take a proactive stance? And that is going to save you a lot of money and a lot of headache. And you could arm, even if a person's still involved with that, you could arm them essentially with the materials that they need to start solutioning that. So you're not just kind of leaving them in the dark to try to figure it out.
Makes a lot of sense. Yeah, if we start with the streaming data, we've already figured out the hard part, right? You make the agents respond to the streaming data, but then also give them the tooling to access the static data. But as you said, that's the easier part. Now, I want to dive a bit further into this idea of stuck on an island. Could you give us a practical business example of this? More specifically, where do we, in this example, see the negative consequences of like a sales agent being unable to communicate with or unaware of a support agent?
Yeah, so I think in that scenario, there's certain things that might exist in the sales system that is important signal information that maybe take into account in the support side of the business,
even the other way around,
or even the other way around.
Sure.
For example, if the customer is at risk of churn, and you're responding either on the sales side or the support side, it's important information to know. But if that's siloed somewhere, or an agent is able to make that determination that the person's at risk of churn, but it only exists in one system, then I can't take advantage of that intelligence in this other system, essentially. So it kind of goes back to like we're creating these intelligence silos that can't do this, sort of inner ecosystem cross communication.
Yeah, because you don't want the sales agent to send this real happy, friendly email of like, hey, I hope you're loving your system, when you know that they have 4 open support cases. Like that would be very inappropriate, but the way things work now, that is the reality. You could be having a terrible support experience, but you're still going to get those marketing emails, which feel pretty bad in that scenario.
I mean, it's a lot like going back to like the challenge around data freshness too. Like if I have some sort of AI system or marketing personalization that's happening and it's sort of operating against a static representation of the customer, it sends an email like, go purchase this product. And it's like, oh, well, they actually did purchase that product. So they are now frustrated because you're telling them to buy something that they just bought. And I think we run into the risk of potential similar level of frustration by creating these different silos in terms of like the AI agents that we're building.
So how does streaming architecture solve this? When do you enable agents to tap into the central stream of data, and what do they gain?
I mean, when you look at data streaming, Confluent's been in this game for a long time. And I think it's really about how do you become like the central nervous system of these different data systems. You're moving data around. That's really where sort of Kafka was originally used. And how do you fan that out to all these different places? That's a very similar problem to cross-communication between agents. Because what is a message between agents? It's just data. You're moving that data from one agentic system to another agentic system, whether that's a multi-agent system that's collaborating or even these agents that exist in different parts of the business. You can use data streaming to essentially be the bridge where those agents shared language, the shared communication becomes events. They're just producing and consuming events, just like we've seen with microservices for the better part of a decade.
So talk to me more about shared context and system level coordination.
Yeah, so in terms of shared context, so what context is in the context of an agent?
The context
is what are you giving the agent for them to understand the task at hand?
Okay.
It's a little bit like, think about context when people communicate. If I just walk up to someone randomly on the street and I say, "Help me," they don't have context for like what kind of help I need. Like I have to give them additional information. Otherwise, they're like, "This person's crazy. Like, get me out of here." Right? And it's similar when you're interacting with these models. I have to essentially, if I went to a model and just said, "Help me" as well, it's not going to understand that. But if I fed in a support doc. Yes. And it had that context, then it's understanding, okay, well, you're probably talking about this particular feature or whatever the support doc's kind of talking about. So you have to correctly contextualize it. Now, in terms of shared context, when we're thinking about like multiple agents that are collaborating and working together, yes. Then one agent that's maybe taking, say, sales lead information, maybe that's the original context. It's going to pull in some additional information about that business and things like that. And it hands off, let's say, the lead score to another agent that's going to figure out, how do we engage this person? Mm-hmm. Well, a lot of that information that was pulled in, that contextual information in the beginning that was pulled in that first agent to score it, is relevant to the second agent that's kind of picking up that work. So that's kind of where this idea of shared context comes front into. In terms of system coordination, it's very similar to when we think about multiple microservices that are interacting or have certain dependencies. We can build those using RPC calls and sort of point-to-point connections, but we have the downside of that is that you end up with this kind of like quadratic explosion of dependencies. And if one part of that graph structure essentially goes down, the whole thing is impacted by it. It's similar with agents. If we have a bunch of point-to-point connections, one agent ends up generating bad output that we don't catch, kind of has potentially catastrophic downstream effects to that. Also, if one agent's not responding for some reason, that also impacts the entire system. So really, event-driven architecture was designed to solve that problem. We decouple these things. Right. We use events to kind of be the shared language. And then we can switch essentially from direct orchestration into choreography, and we don't have these explicit dependencies. And that's really useful when we're building AI systems as well, because a lot of being able to build these things successfully today is a lot of test and iteration. It's like you're changing the prompt, you're changing the model, you're changing the context data, and you need to be able to do this in rapid succession without necessarily impacting all these other dependencies. So I want to be able to launch kind of a sub part of this with a new version and test its behavior before I go and touch other parts of the system.
Yeah, and I guess, again, with data streaming, the persistence, the fan out, all of that kind of comes back to shared context, the system level coordination. It just makes sense as a substrate to facilitate those things.
Yeah, and we talked a lot about fresh data and how important that is.
Absolutely.
Well, even if we forget that the contextual data is ideally fresh, the messages being sent between these systems is also real-time data.
That's true.
All data that gets generated is essentially real-time data. Like
it's not accessed immediately.
Yeah, it's not accessed.
It's written immediately.
Yeah, all data is essentially real time.
It's true.
But we've used batch systems and databases and things like that because we didn't have a way to essentially react and process to it effectively, like historically. And now I think a lot of those challenges are going away. We have effective tools like stream processing to be able to do compute on these things before waiting for them to land. Yeah. Some of the investments that Confluent's making as a company, both in open source and within our products, has been how do you also bring AI to these systems as well? So I don't have to wait for it to land somewhere before I'm, being able to process it within a model.
I have some more product questions for you later, so we're going to dive deeper into that. But I was just thinking about when you talked about, what if one agent created bad data that would have that catastrophic downstream effect? That's where I think stream processing could be really powerful by having some stream processing in the middle that can do some type of validation to say, well, this is way off. This is clearly hallucination. I'm not going to let this get to the rest of the agents. That could be an interesting tool.
I think it's a combination of stream processing as well as schemas that define sort of what the outputs are and data quality rules. I think one of the reasons why sort of the tip of the spear when it comes to AI and sort of pushing the envelope has been engineering is because there are ways of validating essentially things like code.
Right.
Like you can use a model to generate code. I can compile it so I at least know that it's syntactically correct. I can run it. I can run unit tests. I can do integration tests. I can do all these things, these checks and balances to validate it is correct. And if it's not, I could go back and ask the model again. In a lot of domains, we don't have good systems to validate.
Right.
And that's like one of the things that is really, really hard with starting to productionize some of these systems, especially where if the inputs can basically be unbounded, how do I even build a test set to validate the outputs if that's also unbounded?
Right. Yeah, it's a complicated problem. I'm really interested to see how AI helps us fix those AI problems in the future.
Yeah.
Now, once these agents are working together, what's the new, almost futuristic capabilities that get unlocked for a business?
So I think a lot of where we are today is about sort of augmenting existing human processes. So if I'm, need some internal knowledge worker that part of their job is kind of look at multiple systems, stitch multiple pieces of data together just to get to a point where they can analyze the problem and start to solution it. Well, a lot of that models are very good at helping assist in that process today. And these look a little bit more like playbooks and workflows. I don't think they're like fully agentic in the truest sense, where there are potentially some dynamic decisions being made around what data I need to pull in, what tools I need to access or take actions against. But a lot of it is about how do I assist a person on a specific task. I think there are a lot of companies being successful with that today. I think the kind of truly agentic stuff that's a little bit more aspirational is a lot harder to be able to actually put into production in businesses.
Yeah, especially like using your example of unbounded data. And I imagine that's where a lot of the use cases want to be. How do we validate that this answer that we're going to give to a customer is a good one? Because that, like you said, with engineering, that's pretty straightforward. If it's mathematics, that's an easy thing to check as well. But just giving someone advice or, maybe do they qualify for this program? A lot harder to validate. So I'm really interested to see how that's going to work. So to use a music analogy, what can an orchestra of agents achieve that a solo performer never could?
Yeah. So the way I think about it is, to use another real world analogy, to build on your analogy, is like, you don't have one employee in a business that does everything.
That's true.
You have a team of people that work together, that coordinate, that have certain specialized skills that help you solve complex problems. And as you add more people, there are challenges in the communication. That kind of like where some of the things that we're talking about from a data infrastructure standpoint come into play, and good design around like event-driven systems. But essentially, when it comes to agents, there's a lot of downsides of building like a monolithic system, just like there is downsides of building monolithic software. You're tasking one agent potentially with a lot of different goals and tasks that they need to be able to do. And just like a person gets confused by that, the models get confused by it as well. There's lots of studies that will show that if you give the models like too many things to do, too many tools, too many options, too large a piece of content, the things that they remember is maybe the beginning and the end. It's actually very similar to like people. If I gave you a laundry list of 100 different items, maybe you remember at the end of that, like the first couple and the last couple, you probably don't remember the middle. So it's a lot easier for me to come to you and say, I want you to complete this one thing. And then I can go to someone else and I want you to complete this one thing. And the same thing applies to agents. You want to be able to build these things and have some trust and reliability, make them a lot more task oriented.
Sure.
It's in some ways kind of akin to building purpose-built models in the way that we used to, well, we still do, but sort of traditional ML works, but you're not necessarily training and restricting these models to one specific task. They can still be used for different tasks, but for that particular sort of agent's role in the tasks that you want to complete, you're trying to make them more task specific so you can have a little bit more confidence about what it can actually produce. And that also helps you figure out how to actually test it. Because if the one job of the agent is to score a lead, now I know, at least from a validation standpoint, the score needs to probably be between 1 and 100. I know the input is a lead. Anything that's not a lead should not be processed. Any output that's not between 1 and 100, I can ask for it to reprocess, or I can go look at like why it made a mistake.
Sure.
But I'm not sort of polluting the entire system with that misinformation.
Even from an engineering standpoint, it makes sense to break everything up into smaller agents, because how do you make tweaks, right?
Yeah.
Like think about like monoliths versus microservices. You may have teams that own the prompts for these 3 agents, but not these next 10 agents, right? And you wouldn't want to say, oh, I'm going to make this change to the prompt, and you're going to make this change to the prompt in our mono agent, because we already know that's bad methodology. Mm-hmm. So breaking it down for those reasons, in addition to the reasons you stated, make a lot of sense.
Yeah, I mean, I think it's just good sort of software engineering. Yeah. It's like practical computer science skills apply to building agents, just like they have historically applied to any software system.
Absolutely. So now that we've established the power of connected agents, let's discuss A2A, the now open source agent-to-agent communication protocol. What was the origin story here, and what was the problem it was specifically designed to solve?
Yeah, so Google originally came out with this protocol earlier this year, and now it's been donated to the Linux Foundation, and there's a number of different companies that are contributing to it. And what it was originally designed to solve was kind of this island of agents problem that we talked about earlier. If we believe this world where people are going to enterprise businesses are going to have thousands of different agents running in different systems built by different teams. How do we make it so that we don't create these different intelligence silos? How do we essentially facilitate inter-ecosystem communication across various platforms?
Google was trying to get in front of this problem.
Yeah, Google's trying to get in front of this problem. So, a lot of businesses maybe aren't feeling the hurt of this problem just yet, but it's something that's probably imminent to many, many companies as they invest in more and more of these AI systems.
Makes a lot of sense. So, speaking of the protocol, we have a fantastic clip from Merlin from Google breaking this down. So let's roll that now.
I'm Merlin Yamsi, Generative AI Partner Engineering Lead at Google Cloud. Agent-to-agent, or A2A protocol, is Google's answer to this island of agents problems. It's an open protocol that lets agents describe their capabilities, negotiate how to work together, and actually collaborate, no matter who built them. It's designed specifically to handle the dynamic and long-running nature of agent collaboration with enterprise use in mind, secure and governed experience. How does the Google and Confluent partnership benefit you? Together, we provide seamless integration of Confluent's real-time data streaming with Google's AI ecosystem, including models, vector store, BigQuery, and more. Without fresh real-time data, you can't build reliable AI systems, and without models and powerful infrastructure to run those models at scale, you can't make the data do anything of value to your business.
So Merlin mentioned that you need both fresh data and powerful infrastructure to make reliable agentic systems. What's your comments on that clip?
Yeah, I mean, we touched on sort of the needs of fresh data, earlier in the conversation. Clearly, if I'm having an AI system making decisions about customers, real-time product personalization, deciding that an alarm went off in my infrastructure and I need to wake somebody, some poor on-call engineer up at 2 a.m. All those kind of decisions have to essentially have fresh representation of that data in order to make intelligent decisions, just like people do.
Sure.
And in terms of powerful infrastructure, I mean, there's a lot of things where from an infrastructure standpoint, in terms of just running these agents reliably, the agents, not only are they dependent on a sort of non-deterministic model to make certain decisions, but typically agents are also relying a lot of APIs where they're making tool calls and so forth. And their model is deciding about what parameters to pass to those. So you end up with like really kind of a large-scale distributed system problem where people have historically solved a lot of those challenges using, event-driven designs and that kind of, systems like Kafka to help decouple these systems, have that history, be able to retry when, mistakes or faults happen. How do you roll back the tape and essentially make it happen again? Those become even more of a prevalent problem when you're starting to build these agentic systems. So, I mean, that's really what I think Merlin's talking about there.
Absolutely, and more simple. I'm a simple ops guy. You need somewhere to run your agents. You need some type of scaffolding. You need some type of system to do that.
I mean, there's all this message passing that's happening. Sure. There's all the communicating with these external systems as well as internal systems. There's a lot going on, and you don't really want all that data to kind of live and die on the vine of the network call. Ideally, you're fanning those out to multiple systems because you're going to have observability and logging and all that type of stuff on top of that. And you don't want to be just having that message and all the data eventually hit a database where then you hammer the database to fan it out to all these places.
Yeah, absolutely. So let's talk a bit deeper about A2A.
Yeah. So with agent to agent, you have an agent that's maybe running in one type of environment.
Right.
And then it gives you essentially a definition of how that agent can communicate with other types of agents. And those other types of agents can essentially advertise their capabilities so that the model can make a decision of like, okay, well, this agent over here has the information I need or can calculate the information I need. I'll go talk to it.
Right.
But how do you actually deliver the data, the contextual data, and also trigger that agent to do something? Well, you could do that using direct HTTP calls or RPC point to point, but then it has all the downsides of point to point that we've talked about, all the downsides that we've seen for decades now around point to point connections. But if you can back that using an event-driven design, then you can still call the agent, but you have the history of it. You can fan that out to multiple systems. You have the retries and the reliabilities built into it. Also, a big part of, I think, building reliable agents is being able to test new versions of that agent. And if you're using something like an immutable log or Kafka essentially to be the backbone of the messaging system, you can replay those logs because it's the new version.
So you get what you want.
It becomes essentially a way to build evals based on live data.
Makes a lot of sense.
So there's a lot of like nice characteristics of it that we've been using historically for powering microservices for a long time, but they apply to these systems as well.
Right. I think that's really the core of it, right? Mm-hmm. All the things and the reason why people have driven towards event-driven architecture is because of the benefits it has, especially when you're talking about more compartmentalized compute, in this case, compartmentalized intelligence. So again, if you have any doubt, think about how you build microservices. You should build your agents the same way.
Yeah.
So now we know how and why agents should talk to each other. But what about everything else? How does MCP or the Model Context Protocol allow agents to access other critical resources like a vector database or a traditional API?
Yeah, so MCP or Model Context Protocol from Anthropic was a standard that was proposed last year in around November, I believe. And the problem that they were solving or trying to solve is kind of similar to the agent-to-agent problem, but specific to tools. So if I'm building an agent, a lot of times a characteristic of the agent is that I can use the model to make decisions about what data I'm going to pull in or what actions I might take. And all those essentially can be what we call like tool calls. So I can define to the model, like, here's all the API endpoints I have or the functions that are available. Here's the parameters that I take and a description of what that functionality is. And then the model will essentially decide, do I need to call one of these in order to get enough information in order to accomplish my goals? And you can go through essentially this like reasoning loop of that. And the model is going to pass back. It doesn't call the tool directly. It passes back, hey, here's the function you should call and here's the parameters that you should call it with. Now, if I'm building one agent that talks to 3 different tools, no problem. Like I can do that. I can hand code that. I can build that any way I want.
Easy.
No big deal.
Yeah.
But as soon as I start, my business starts to build 10 agents that maybe are talking to some of the same tool endpoints as well as some new ones, suddenly, one, you get this explosion of various like sort of point-to-point connections between the different tools, but also I can't take advantage of another team's integration necessarily. There's no sort of standard around it. Everybody's kind of writing bespoke code to interconnect these systems, a little bit like data ingestion. If everybody's writing their own data ingestion, scripts, then suddenly that's a lot to manage and it becomes really problematic over time. And you take on essentially a lot of technical debt with that. That same thing's happening with agents already because it doesn't take that many agents before you start to feel this tool pain. So what MCP does is it standardizes essentially how you do tool calling. It's a client-server model. So the agent itself essentially would have something like an MCP client in it. When it spins up, it's going to know which servers it can talk to, and it does a handshake. It calls out the servers. The servers say, hey, here's my capabilities and the tools I have available, the description of them. And then that's taken into account when the model's called, that context about the tools available will be passed in, and then the model will decide, okay, well, you should go talk to this tool at this endpoint, and the client knows how to translate that essentially.
That makes a lot of sense. So MCP is about enabling the individual agent, even though the MCP server might be used by multiple agents for tooling. A2A is all about empowering the agents to be aware of each other and how to communicate with each other.
Yeah.
So while both of those are incredibly powerful together, how does a developer actually get started building one of these agents? So let's talk about the Agent Development Kit or the ADK. What does it provide?
Yeah, so development kits like ADK, they give you essentially an abstraction for how to put together an agent. Right. It's almost like a very high level description of what the agent is. So typically you're going to have essentially in whatever programming language of your choice, you're going to find an agent, class structure or object, and you're going to say, here's the role that you're supposed to perform. Here are the tools you have or the MCP servers that you have. Right. And essentially the toolkit is going to take it on the responsibility of actually running that agent and doing all that inference loop, calling the tools or the functions, the MCP servers. You don't have to build that stuff yourself. It's abstracted away. So you're really kind of defining these things with a fairly high level abstraction that most of it's actually expressed in natural language. Wow. Here's your role. Here's the tasks I want to have you complete. Here's, maybe additional contextual data that you need to take into account. But in terms of all the tool calling, the looping, the inference loops, and things like that, it basically abstracts that away.
Makes sense. Gives you not only the toolkit, but the framework to start building those agents and start implementing tools like A2A and MCP. Yeah. So now talk to me about the Google and Confluent partnership. How does our Better Together story provide customers with a complete end-to-end solution for building real-time multi-agent AI systems?
Yeah, so it's a great question. So, Confluent's really focused on how do we enable customers to essentially tap into the sources of their data. A lot of these like operational systems, whether you're doing CDC from a database or you're collecting mobile app data, you have all this user behavior data that's flowing through your data streams today. And you can use things like stream processing to build up various signals and understanding about what's actually happening. And then with Google's really providing the tooling through things like A2A, where we can do cross-platform communication. So you could be using something like a streaming agent built in Confluent Cloud, but that streaming agent could communicate with agents externally through something like A2A that you're building using ADK, because another team is decided that was the right framework and the right system for them to build those things.
Right. Excellent. So really the combination of technologies just really give the end customers the freedom to build anything and everything they want.
Yeah, I think you want to give basically people the ability to be adaptable, especially right now where we're trying to build these like beautiful castles off of like really fragile foundation that's kind of shaky and it's got some cracks in it and stuff like that, because the models are changing all the time. The approaches, the frameworks are shifting all the time. So you have to be building and architecting for adaptability from the get-go. That's why I keep, I probably said this 100 times in this conversation, but I keep preaching like event-driven design, because you can decouple these systems, microservices. You have to be kind of having that system design level thinking when putting and composing these things.
Yeah, you don't want your castle to slide into the ocean.
Yeah.
So we've covered a lot of ground. And I think, for many people, real life use cases or examples are kind of what tie everything together. So taking these pieces, data streaming agents, A2A, and the tooling, how could these come together to solve a problem for a retail company?
Yeah, so I think in the retail, a lot of what people are interested in is being able to create, highly personalized experiences. And retailers have been doing this for a long time in some fashion, using sort of traditional ML and other techniques. But now with these powerful models and agentic systems, you can make it really, really personal and reactive if you start to think about this as real-time data. So as somebody's on my site, maybe they have put certain things into a cart, or they're even looked at certain product pages for certain periods of time. Well, all that information, those types of events, retailers are already sending those over data streams.
Right.
Like there's so much visibility into what customers are doing on a website or in a mobile app or all these different places. And you can use stream processing to essentially figure out what is the signal with which I want to engage. And maybe it's like after 10 minutes of the person lingering on a product site page, it's like, okay, well, how do we nudge this person forward? Right. And then when you start to build agents directly in the stream, that streaming agent could be doing real-time price analysis against competitive products. You could be bringing in other information about the customer based on maybe their past purchase history to try to create essentially a compelling offer. When you think about e-commerce or retailers, like if you've captured someone's attention and their eyeballs, you don't want to wait even an hour or the next day or certainly the next week, and just send them an email and try to engage them. Like that's just going to be, you're throwing money away at that point. So you want to be able to do it in the moment, but you don't also just want to send them something that's noisy. You want to create something that's personal.
Right. Right. Even an email that doesn't look like the next person's email, right? Because right now they're all templatized. But in the world of artificial intelligence, you could have something and probably even get signals that maybe even seem scary from some people, but really give an email, a communication that will really target and really get that person's interest. I think that's pretty interesting. Now, let's tap another industry. Do you have any examples for maybe financial services or maybe industrial IoT?
Yeah, I mean, I think common things, like if we take the IoT example, there's a lot of, things like either IoT devices, or you think about like even manufacturing. Historically, a lot of those companies use event streaming for essentially getting signal information off of these different things. Like, and they want to be able to, they're collecting a lot of information about that, but they also ideally want to know if any of those devices are at risk of failing.
Right.
And then can you self-heal? Can you self-diagnose? That type of stuff. So those all become eventually sort of the natural extension of sort of the rudimentary stuff that we used to do in the past for that can become more of these like agentic workflows where you can start to actually solution it. You can offer suggestions, or you can even maybe take certain actions to self-heal or fix the problem and stuff like that,
right,
or loop in someone.
Maybe don't trigger actions just based on like a high watermark or a low watermark. Maybe you even can start to trigger actions based on rate of change, or maybe external metrics that we wouldn't be able to simply put into it if then stated.
Yeah, I mean, I think about things like real-time inventory balancing between either different, factories or even different retailers. Like if you have multiple, of the same branch retailer in a particular geo, one place is running out of toilet paper, another place has a surplus of toilet paper. But those are important signals. You can, fix that problem if you essentially architected it correctly and you're using the right data systems.
Yeah, even external news, like there's suddenly a lumber shortage, right? Which may not, may not appear on an inventory report. If an agent had access to that, it might be able to predict downstream, okay, we're going to run into a problem. Let's get in front of this. Let's over order because we know that this particular product line is going to be affected.
Yeah, and those types of things, those signals are really important when you think about financial services, trading, all these types of things. All those things, people like quants have been, building systems like that for a very long time. Now, I think with some of these powerful models and also some of the systems that we're building to be able to actually process this information is empowering other people to build sort of more these like really sophisticated systems that really before only like a handful of companies or specialists in the world could do. Now I think you're empowering a lot more people to be able to build those things.
That broad adoption of this like highly effective systems. So now to make these use cases easier to achieve, let's discuss key GenAI features on Confluent Cloud that are available today, which are helping developers build, deploy, and manage these complex systems. Can you take us through those features?
Yeah, absolutely. I mean, the way I think about this, and we've touched on this a little bit, is we've really been trying to bring AI closer to data streaming.
Of course.
Because there's a lot of rich, valuable information that's flowing from these streams, signal information about what your customer is doing, all this type of data. So you want to be able to make those systems essentially as reactive as possible. So essentially you can be proactive as a business.
Of course.
So in terms of actual features, we have now built-in ML functionality. I think of these as kind of like easy buttons for AI. I can do anomaly detection with a function. I can do forecasting, these types of things that many businesses have been building and using for a long time. And then sort of on the sort of Gen AI side, we've had support for using AI models directly within our managed Flink offering for a long time. We've also contributed that back to open source. So now I can bring the full weight of a foundation model into the data stream to be able to do things like real-time inference. So I can take product reviews that are flowing in and do real-time thematic analysis on that. Or I could do real-time sentiment analysis or score it or a bunch of different things to figure out, do we have a problem right now that we should get out ahead of it? And I don't have to do this as some sort of post-analysis step. Or even at Confluent, the way we do lead scoring, those sales leads flow through Salesforce. They would go to a Kafka topic. Then we use essentially Flink and inference against the lead scoring model to score those and have essentially a real-time feed about the quality of the lead. And a natural extension of that is now how do we actually go and action some of those leads? And that's where our streaming agents product comes into play, where we can go beyond just one-shot inference to be able to support full agentic systems that operate on the stream, doing tool calling, supporting MCP, all the kind of standard things that you see in any agentic framework.
So that's what exists today. But how about a peek on what's on the horizon? What upcoming tooling or features are you most excited about that are coming to Confluent Cloud in the context of agentic AI?
Yeah, I mean, I think I'm really excited about the continuation and enhancements around streaming agents.
Yeah.
So streaming agents is a recent launch for us.
Yeah, it is.
There's, I think we have a lot of customers engaged with it. People are excited about it. I'm excited about it. Team's excited about it, which is great. But there's still a lot of work, I think, to be done. So we're working on things and making it a really delightful developer experience, having all the sort of traditional semantics around it, supporting other protocols and standards like A2A to support these inter-agent communication and so forth. It's also, these things don't exist in silos. They're ecosystems. You don't build an AI system or any really software system with one vendor. So there's also a partnership angle to all of this as well, where we're building up those partnerships. We're making those integrations available so that you have these easy buttons. I talked about the easy buttons around anomaly detection, around forecasting, but I think agents should also eventually be easy buttons that anybody can leverage.
Absolutely. Like your point before about these systems being limited to just a small pocket of people. The more accessible we can make agents, the better I think the future of agentic AI will be. Mm-hmm. Now, to wrap up, what is the single most important takeaway you want our audience to remember about the future of AI and the critical role that data streaming plays in it?
Well, I think the biggest thing, and I think is really understanding why this fresh information is critical for building these systems. And I think that it's not always thought of that way because of just the historical way that we've used sort of traditional ML and analytics, and we automatically sort of bucket using foundation models and agents into this like post-analysis step. But these are not dashboards. Like they could be dashboards, sure, that's fine, that's a use case. But if you want to really be able to transform your business and be able to take a proactive approach, be able to augment a lot of your existing workforce to help them be more efficient, so that you're reacting to the signals that are actually happening, business events that are happening, you need to kind of change your mindset around this and be thinking about, how do I actually take a proactive stance and know what's going on in my business, shift a lot of that sort of responsibility left. And we've seen that kind of shift left stance in many, many businesses over the last, several decades, certainly in my lifetime in business. When I first started as an engineer, testing was essentially you write code, you checked it in, you threw it over a wall to a QA department, and then they would test it, they'd find problems, they throw it back over the wall. I
remember those days.
Now and I think if you told engineers at the time that they were going to be responsible for testing, they'd be like, whoa, we can't do that. There's no way. But what has happened, we've shifted that responsibility left.
Sure.
Because the creator of the code is in a better position to essentially figure out what the test should be. And it doesn't mean QA has gone away. People still QA these things.
Sure.
But now you're leveraging them to do something more than just like basic testing. And I think data has to go through a similar transformation of shifting the definition of the data product, the schemas, all that stuff left, closer to the source. And those people also have a lot more knowledge about what that is. And if you do that, then suddenly it opens up new use cases around the AI and agentic AI that every company wants to invest in, but most companies aren't ready to be able to take advantage of it because their data systems aren't ready.
Yeah, if you understand the source of your data, you understand the challenges you're trying to address with that data, suddenly you're building better systems. Well, thank you so much, Sean. I really appreciate your time, and that was extremely insightful. For everyone, thank you for joining us for this very special edition of Life is But a Stream. I'm your host, Joseph Bonais, and as always, happy streaming.